A group of mathematics students decide to produce some badges to publicize the coolness of their subject. They decide to produce two different badges, one with the slogan "Maths Rules" and the other with the slogan "Maths Rocks." They decide that the total number of badges produced needs to be between 30 and 50, inclusive of 30 and 50. They need to produce at least twice as many rules as rocks, and they must produce at least 10 rocks. Produce a graph to show their possible production. Let the number of rules badges be X, and the number of rocks badges be Y. We know that we need to have between 30 and 50 as the total number of badges. The total number of badges will be X plus Y, since we have X rules badges and Y rocks badges. The total number of badges will be X plus Y. This must be greater than or equal to 30. It must also be less than or equal to 50. They must produce at least 10 rocks badges, so Y, the number of rocks badges, must be greater than or equal to 10. We're now told that they need to produce at least twice as many rules as rocks. Consider this is the number of rocks. This is the number of rules. So twice the number of rocks would be 2 times Y. We have to produce at least this many, so X is greater than or equal to 2Y. We can rewrite this as Y is less than or equal to a half of X. We now have all of our inequalities. We want to represent these on a graph. Let's start with Y is greater than or equal to 10. We need to draw the line Y is equal to 10. It needs to be solid, we need to label it, and we need to be above it. Now let's look at Y is less than or equal to a half X. We need to draw the line Y equals a half X. This might require a table of values. If X is 0, half of 0 is 0. If X is 10, a half of 10 is 5. And if X is 20, a half of 20 is 10. So plot 0, 0, 10, 5, and 20, 10. We need a straight line which is solid and goes through all of these points. Don't forget to label the line. We need a test point to decide which side of Y equals a half X we want. I'm going to use the point 0, 20. X is 0 and Y is 20. So Y is 20, a half of 0 is 0, and 20 is greater than 0. Therefore, this point does not lie in the region Y is less than or equal to a half X. Therefore, we need to be below this line. Consider the inequality X plus Y is greater than or equal to 30. We need a table of values to to draw the line x plus y is equal to 30. If x is 0, y is 30. If x is 10, y is 20. And if x is 20, y is 10. So we have 0, 30, 10, 20, 20, 10. Draw a line through these 3 points, and we could use a test point to decide which side we need to be, and we'd find this side. Now for x plus y is less than or equal to 50, we need to draw the line x plus y is equal to 50. A table of values. X and y. If x is 0, y is 50. If x is 10, y is 40. And if x is 20, y is 30. So we have 0, 50, 10, 40, 20, 30, and we need to draw a straight line through these points. Once again, we could use a test value, and we'd find that we need to be this side of this line. Between these lines, below this one and above this one, is this triangle here. Here we have a neater picture of the region. Remember that we're producing numbers of badges. Therefore, the production level must be at integer valued coordinates. We have to produce whole numbers of both types of badge. Any point in this region, which includes the solid lines, would be a level of production that fits with all of the information given. For example, let's pick this point here. At this point, x is 35 and y is 10. This corresponds to 35 rules badges and 10 rocks badges. Any other point in the region where both of the coordinates are whole numbers is a feasible level of production.